Okay, well, it asked us to find, like, the trajectory of a rocket and stuff, and we had to find what time they should set the timing mechanism for so it'd blow up at the highest peak, how long the rocket would be in the air for, and how high the rocket would go. So they gave us an equation in the book, which we didn't write up here, and we just started plugging numbers in for, say, like 3 for 3 seconds, and then that would get you like 200 feet. So then we started plotting the seconds over here on the graph.
Okay, we went and added in 1 second increments, so at 0 seconds it'd be at 160, for 1 second it'd be at 236, and so on, and we found that after 3 seconds the height starts to go down.
And 7.1 seconds, that's when it hit the ground.
Yeah, so that was how long the rocket would be in the air for, was 7.5 seconds. We found the rocket would go a total of would be as 292 feet high at its highest point, and then we found they should set the timing mechanism for 3 seconds because that was if they wanted it to explode at its highest point.
Very good.
And all the points made a palabra.
Very good. Right, group?
Okay, our and out table, we had time for in and height for the out. And we started with 1, and that was at 236. And then after 3 seconds, it started to go back down. We plugged them into the T to get our out.
As you can see here are the questions. How long to the top will take the rocket 3 seconds to reach and the maximum height of 292 feet? What's the best place to stand? We didn't answer that one. How high will the rocket go? The rocket will go 292 feet. And how long will the rocket be in the air? The rocket will be in the air for 7.3 seconds. Here's how we used it.
And we substituted like the time in for T on our formula since the T represents the time, and that's how we found these.
And me. Alright, and here's our gorgeous graph. And we made a palabra, whatever that word was. But we knew that it had to start at 160 because that's the height of the building. And we plugged in our numbers from up here. So like 1, 236. So yeah, you go up to 236, and then the next number, 2, 280. You go to that number, but then it starts reducing. So you go down, and down, and down, and down, until you reach that point, which is 7 and something.
Good job. Next. Which group is gonna go?
So on number 1, we created a palabra, which is showing the trajectory of the rocket. And at 0 seconds, it started at 160 feet because it started on the tower. And it kept going up until it hit about 3 seconds is at 292 feet, which was the highest point it was at. And it started decreasing all the way until it hit the ground at 7.15 seconds.
One of our questions for Hannah's equation was, what is the rocket's higher trajectory? And how many seconds does the rocket take to reach its highest trajectory, and how many seconds will the rocket be in the air?
And number 3 is we used Hannah's formula to find the highest trajectory of the rocket by plugging in the different second intervals. You can also use the formula to figure out the time spent in the air.
Number 4, the rocket's highest trajectory is 292 feet. The rocket takes 3 seconds to reach its highest trajectory. The rocket will be in the air for approximately 7 and a 7th second.
Next.
Well, this is our sketch of a graph.
Well, the soccer team wanted to know where to make the rocket explode because it wanted it on its highest part, and where to make it land, and then where to have the people sit to get the very best view of the rockets.
So this is our in-out table. We started with 1. We plugged it into the equation and got 236. And if you work it down, then when you get to 3, it's 292, which is the highest.
They wanted to make the rocket explode at 3 seconds after the takeoff, and then the rocket was going to land 7 1/7 after takeoff.
Well, the graph, okay, at 0 seconds, it's at 160 feet. 1 second, it's at 236 feet. 2 seconds, it's at 280 feet. 3 seconds, it's at 292 feet, which is the highest point.
Very good. Next.
The soccer team wanted to know how long it would take the rocket to stay in the air, and we found that it would be 7.2 seconds. They also wanted to know how high it will go, and it ended up being 292 feet. And how long does it take to reach the highest point? It took 3 seconds. So it took 3 seconds to go 292 feet and 7.2 seconds to go all the way in the air and hit the ground.
We graphed it, and we showed to our highest, which is 292, and then our lowest is 0 for 7.2 seconds.
And then we made an in-out table, and we started with 0 and 60, and we went down to 8 and negative 128, and we figured out the difference, and it was 76 and 44, and the difference of those were 32.
And we found these numbers by plugging each number for the n, which was the seconds, into this equation, which was the equation that they gave us for the beginning point, how long it went each second, and the force of gravity. So then we just plugged each number into the equation, and that's how we got our out, which was the height.
Very good. And last but not least, I believe.
And the book gave us the quadratic function, which was right here, which is h equals 160 plus 92 times the time minus 16 times the time squared, and h represents the height of the rocket. So we graphed it right here, and since it is being fired off of a tower that is 160 feet high, then when it starts, it'll be 160 feet high. And then each second, it goes up 92, it would go up like 92t minus 16t squared. So then we just use that, and then we figured out the parabola that it makes.
Number 2, the soccer team wants to know at what time to make the rocket explode and where to have the spectators sit.
Number 3, how you use this in your problem. You would substitute your time in seconds for t and solve the equation, and you would find the height of the rocket at that time. And so if you put 1 in for t, you get 236 feet.
And for number 4, the team should make the rocket explode 3 seconds into the flight, because at 3 seconds is when the rocket reaches its peak, and then they should tell the spectators to sit at a reasonable distance of about 40 to 50 feet from the tower.
Very good, kids. My question for you is on number 4, or on the question where it asks how long is it in the air, or how long does it take till it hits the ground. What did you know in that? What did you know, and what were you trying to find? That h equals 0, and you were trying to find the time. How did you do it? Backwards. You kind of had to guess and check, correct? Okay. For the highest point, how did you know 3 seconds was the highest point?
Because after that, all the other points were lower.
Okay, started going lower then. Did anybody try 3.1 seconds? How do we know it didn't go higher at that point?
Because I'm a pyro.
Okay, eventually we are going to find out the highest point, and we'll be able to do it algebraically. And very soon you'll figure that out. Also, we'll be able to figure out how long the rocket is in the air algebraically. So